In this video, we'll review some basic definitions of the process of conducting statistical study. We'll learn how to distinguish between parameter and statistic, quantitative and qualitative data, discrete and continuous data, how to define and identify sampling methods, and understand the importance of the good design of experiment. Consider the process that involves in conducting statistical study. We begin our preparation by considering the context of the data. The second step in preparation process is to consider the source of the data. We conclude our preparation by considering the sampling method. Choosing a good sampling method is absolutely essential for sound results in a statistical study. It is generally a bad practice to use voluntary response or self-selected samples, even though their use is common. We'll talk about sampling methods later in the video. After completing our preparation, we begin to analyze the data. An analysis should begin with appropriate graphs and exploration of the data. We'll discuss the graphs in more details in Chapter 2 and important statistic in Chapter 3. Later chapters describe important statistical methods, but application of these methods is often easy with technology, such as calculators, statistical software packages. Remember that a good statistical analysis does not require strong computational skills. A good statistical analysis, however, does require using common sense and paying careful attention to sound statistical methods. The final step in our statistical process involves conclusions, and we should develop the ability to distinguish between statistical significance and practical significance. Let's review how to identify whether the results have statistical significance and/or practical significance. Statistical significance is achieved in a study when we get a result that is very unlikely, we say 5% or less, to occur by chance. Practical significance refers to a magnitude of the difference. The results are practically significant when the difference is large enough to be meaningful in real life. What is meaningful may be subjective and may depend on the context. The results can be statistical and practical significant, or they can be neither, or either statistical or practical significant. Before we talk about sampling methods, let's stop on converting percentages to decimals, fractions, and vice versa. To convert decimal to percentage, we move decimal point 2 times to the right. Let's convert 0.3 to percentage. Percent means 100. Therefore, to convert 0.3 as a decimal to percentage, we multiply by 100 and add the percent sign. Multiply by 100, meaning we move decimal point 2 times to the right. We add the 0 for the missing spaces. 0.3 equals 30%. To convert fraction to percentage, we do the same thing. We multiply by 100. Let's convert 3/4 to percentages. 3/4 times 100, and then we add the percent sign. To multiply fractions, we multiply numerators and denominators and reduce whenever possible. In this case, it's possible to reduce 104 by 4. 3 times 25 equals 75%. To convert percent to decimal, we need to get rid of this percent sign. Percent means per 100, so we divide by 100. 85% divided by 100 and remove the percent sign. 85 divided by 100, move decimal point 2 times to the left, 0.85. So 85% as a decimal is 0.85 or 0.85. Find 6% of 1,200. To find percentage of a number, we multiply percent as a decimal by that number. 6% as a decimal, we need to divide by 100, so we move decimal point 2 times to the left, add the 0 for the missing space. 0.06 of means multiply times 1,200 equal to 72. We will now discuss sampling methods, which involve probability sampling, simple random sample, stratified random sample, systematic sample, and clustered random sample, and non-probability sampling, convenience, judgmental, and snowball sampling. Remember how important it is that the sample data are collected in appropriate way. Simple random sample is identified when a sample of n subject is selected in such way that every possible sample of the same size n has the same chance of being chosen. Systematic sampling is collected when we start at some point and then select every kth element in the population. Stratified sampling is collected by subdividing the population into at least 2 different subgroups or stratas so that the subject within the same subgroup share the same characteristic. Then draw a sample from each subgroup or stratum. Cluster sampling is performed by dividing the population areas into sections or clusters, then randomly selecting some of those clusters and choosing all of the members from those selected clusters. Opinion sampling or voluntary sampling is the least sound method of sampling when we use data that are very easy to get. Judgmental sampling is performed by selecting a group of people because they have particular traits that the researcher wants to study. And snowball, also known as chain referral sampling, performed when the researchers recruit initial subjects to be in a study and then ask those initial subjects to recruit additional subjects to be in the study. In statistics, we use variables to conduct statistical study. Variable is any characteristic of some event, object, or person that can be taken on different values or amounts. A variable may also be called a data item. It is called a variable because the value may vary between data units in the population and may change in value over time. Variables can be categorical or qualitative, that consist of names or labels, and numerical or quantitative, consist of numbers representing counts or measurements. Qualitative variables are descriptive, and computing mean and standard deviation for them does not make sense, whereas quantitative variables have same meaning, so statistics such as means and standard deviations make sense. Categorical or qualitative variable can be nominal, unordered categories which are mutually exclusive, such as male, female, smoker, non-smoker, and ordinal variables that can be ordered categories which are mutually exclusive, such as minimal, moderate, several, unbearable pain level. Numerical or quantitative variable can be discrete, a whole number value typically that we can count, such as number of visits to the dentist and so on. And continuous. Continuous variable can take any value with a range, such as height in centimeters, pocket depth. In the 1940s, Stanley Smith Stevens introduced 4 levels or scales of measurement: nominal, ordinal, interval, and ratio. They are still widely used today as a way to describe a characteristic of a variable. Nominal level of measurement is used for categories only. Data cannot be arranged in order. For example, eye colors, social security numbers. Ordinal level of measurement consists of data that can be arranged in order, but the difference either cannot be found or are meaningless. For example, ranks of colleges or rating excellent, good, fair, poor, or course grades. We can order them, but we cannot find the difference because the difference would be meaningless. Interval level of measurement, when the differences are meaningful, but there is no natural zero starting point, and ratios are meaningless. For example, such as temperatures in degrees, years, and so on. Ratio level of measurement is considered the higher level of measurement. It has a natural zero as a starting point, and ratios make sense. For example, heights, lengths, distances, class times. Here is a summary of the levels of measurement with a nice table. How to identify which level of measurement we use in different cases. Remember, nominal, categories only. Ordinal, categories with some order. Interval, differences can be found but no natural zero. And ratio, differences can be found and there is a zero as a starting point. When using statistical study, planning is very important, and it is essential that we use an appropriate method for collecting the sample data. In an experiment, we apply some treatment and then proceed to observe its effect on the individuals. In the observational study, we observe and measure specific characteristics, but we do not attempt to modify the individual being studied. Some data should be collected in the experimental study and some using the observation. For example, if we want to measure the effectiveness of a medical treatment, we would want to conduct the experiment. But if we want to study the correlation between texting and driving, we would be performing the observational study and not the experiment. There are several types of observational studies. Retrospective or case control study, when data are collected from a past time period by going back in time through the examination of records, interviews, and so on. Cross-sectional study, when data are observed, measured, and collected at one point in time, not over a period of time. And perspective or cohort study, data are collected in the future from groups sharing common factors. In statistics, you could use a good sampling method and do everything correctly, and yet it is possible to get wrong results. No matter how well you plan and execute the sample collection process, there is likely to be some error in the result. The different types of sampling errors are described here. The first error is called sampling error. It occurs when the sample has been selected with a random method, but there is a discrepancy between a sample result and the true population result, such as error results from chance sample fluctuations. The other type is non-sampling error, when the result of human error, which includes such factors as wrong data entries, computing errors, questions with biased wording, false data provided by respondents, forming biased conclusions, or applying statistical methods that are not appropriate for the circumstances. Finally, non-random sampling error, when the result of using a sampling method that is not random, such as using a convenience sample or a voluntary response sample.